Hi, everybody. Welcome back to the exam number 4 review. For the first video, we did 4 problems. So today we'll start problem number 5. So the problem number 5 is a quadratic functions. F of x equal to the x squared minus 2x minus 8. So we're going to find those typical things of where is the vertex, axis of a symmetric, and x-intercept and y-intercept. Right? So the first thing here, let's review here, right? So the vertex is here, right? So let's do a quick review. The vertex here. So for the vertex, the x coordinates will be what? Like a negative b minus over 2a, right? So let's take a look at these problems here. So the first thing here, this is my b's, right? Now here is a 1x squared. It does not have 1, so we know this is 1. So this is my a. Then this one is c here, right? So this is how do we write the standard quadratic form, a squared plus b squared. Okay, so the vertex here, the x coordinates will be what here? Negative b over what? 2a. So here that will be what? 2 times 1 is 2. Negative b is negative 2, right? So it's negative, so it becomes 2 over 2, so it's 1. Okay, so after you get this 1, in order to get y coordinates, what you need to do, you need to substitute the 1 to your functions, right? So that means everything in the function f of x, is x you replace with 1. So this is 1 squared minus 2 times 1 minus 8. So 1 minus 2 minus 8 is what? It's negative 9 here, right? Okay, so that's why the first thing we find our vertex here. This is the 1 and the negative 9. And the axis of the symmetrics. So we know the axis of the symmetrics is, so let's take a look at the review here. The axis of the symmetric. Anybody remember axis of symmetric? Axis of the symmetric is x equal to what? X equal to whatever you figure from here, right? So it's the vertex is x coordinates. So that's what is the negative 2b over negative b over 2a. So the axis of the symmetrics here is x equal to what? X equal to 1. So let's try to plot those points first, right? So x vertex is 1, negative 9. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So here, this is my vertex, right? So this is 1, negative 9. Then we know the axis of the symmetrics, so it's like the line here. Okay, so it's kind of like this is the line we'll talk about. Oh boy, that's not good. Okay, so the last will be the line. So let me see here, can draw better. Right, okay, not bad, not bad. So this is the axis of the symmetrics. That means your graph going to kind of the symmetrics to this. Okay, next thing here, let's take a look at what is the, so in here, the next ones here is let's review what is the x-intercept, right? So just like we do the linear functions, the x-intercept, what is the x-intercept? So x-intercept is y equal to 0. Okay, so now let's try to solve it. So that's what we know. The x-intercept is set y equal to 0. So that means 0 is equal to x squared minus 2x minus 8. Then we factor. So this is max x negative 2 and x plus 2, right? So now you set each one equal to 0. So x minus 4 equal to 0. So x equal to 4. Then x plus 2 equal to 0. Then x equal to negative 2. So those are the two, the x-intercept here, right? So I have two x-intercept. So it will be 4, 0, and then negative 2, 0. Okay, so now let's graph it. 2, 4 zeros, 1, 2, 3, 4. So this one is here. Then the next one is negative 2. So 1, 2. So it's here. So those are the two x-intercept, right? Okay, so far so good. Now the next one here is y-intercept. Y-intercept is easy. So the y-intercept, so you dot x equal to 0. Try to find the y-intercept. So that means that means everything in the x you become 0. So it's 0 squared minus 2 times 0 minus 8. So this is negative 8 here, right? So I know the y-intercept here. I can rewrite this. This is 0, negative 8. So that's y-intercept. Okay, now let's plot the points here. The y-intercept is 0, negative 8. So it's here. Okay, so now my challenge is here. How do I graph it? I hope I know I'm not going to graph a beautiful protracted, but here you will see that's what is the not too bad, right? So you can see this is a kind of that's what is our graph looks like, right? So it's not too bad. It's like it's pretty good. Like we can graph it in the on the whiteboard. It's not easy to graph it here. Okay, so sounds good. Okay, so now let's go to the next province here. This is the example. That is the problem number what? It's number 6. So we have 2 parts. So let's do the 2 parts together. So let's see here. So this is f of x is equal to what is here? This is x minus 1. This is x plus 2. And this is f of x is equal to x squared minus 4x minus 21 x plus 3. All right. Okay, so the first thing is to ask is the vertical asymptote. Okay, so the vertical asymptote, so let's use the VA to represent. So VA. So let's try to put the vertical asymptote. So review. So how do I get the vertical asymptotes here? Is when denominator equal to 0, right? So that's how do I get the vertical asymptote. So for here, the denominator is x plus 2, right? So the way to find the x is x plus 2 equal to 0. That means my x equal to negative 2. So that's why this is my vertical asymptotes here. Okay, so for the problem B here, right? So we need to be careful here. So for your functions, right? First things you want to take a look to see you be able to factor or not. So like in this ones here, you can factor here. So this one's here, this is x minus 7, x plus 3. Okay. I'm not going to, you know, so here, I just want to show you here, the x plus 3, you can cancel here, right? Okay, so when I'm looking for the vertical asymptotes, I don't have denominators here. So I only have x minus 7. So for this function, the vertical asymptote is what? Do not exist, right? DNE. So this one is do not exist. Be very careful. Okay, so now the horizontal asymptotes here. Okay, so horizontal asymptotes here. Okay, so the horizontal asymptote, let's try to review. So what is the horizontal asymptote? We are comparing the degrees of the polynomial on the numerator and the denominator. Okay, so in here, let's take a look here. For the A, this is x minus 1. So I know this degree is 1. This is degree is 1, right? So based on what we learned before, if the degrees are the same, then will just be the ratio of the leading coefficients. And also in here, because this is x's, right? So I know my leading coefficient here is just 1. Here is just 1 here. So that's why the horizontal asymptote will just be what? Is y equal to what? Y equal to the leading coefficients 1 over 1, right? So the that will be equal to 1. So y equal to 1 is what? Y equal to 1 is my horizontal asymptotes here. Okay. Okay. Now let's see here the holes here. Oh, I'm sorry, here. We don't have the here. So the horizontal asymptote is a compare, right? The denominator and the numerator. So take a look here. I don't have the denominator anymore. So it's x minus 7. So when x approach to infinity, so these ones do not exist neither, right? So the horizontal asymptote is not exist because you don't have the, so the, you know, the top is 1 and the bottom, the degree is 0. So you don't have that. The holes here, right? So if you remember the holes is the number make the denominator equal to 0, but can be canceled out by factoring. Okay, so so like in here, you know, take a look here. So for here, the one make the denominator equal to 0 is x minus x equal to -2. But these ones here is nothing to cancel out by the factoring. So the holes for these ones here do not exist. So this one does not have a hole here. Okay, now for these ones here, let's take a look at these ones here, the holes here, right? So the holes here is the one, you know, make the denominator equal to 0, but can be canceled out. So take a look here. This is the one make the denominator equal to 0, but after you factor, they can cancel it out. So the holes here is what? So the holes here is x equal to -3. So is what is the value? So that means this is x plus 3 equal to 0. So that's why you get x equal to the -3. So that is the holes here, okay? Okay, now let's try to graph these ones here, right? Okay, so the way we graph it here, so let's take a look here. Okay, so hope the, okay. Okay, and now in here, we have this is 1, 2, 1, 2, 1, 2, 3, 1, 2, 3. Okay, so the first thing is here, in order to graph it, and I know my vertical asymptote is at where? My vertical asymptote is at -2, right? So at -2 is here, okay? So my vertical asymptote is here. So let's try to graph a line to show this is my vertical asymptote. Good. Okay, then my horizontal asymptote is at y equal to 1, right? So y equal to 1, so let's make a horizontal asymptote here. Okay, so this is my horizontal asymptote. Now I can graph my function. In order to graph the function, I need to know how light turns, right? So you can choose several points here to help you to decide. So this is x, right? So you turn, this is x, this is y. Try to see x equal to 0. So 0 minus 1 is -1, so it's -1/2. So your points here is 0 and -1/2. So it's somewhere in here. Then choose another point. You said x equal to 1. Let's see, x equal to 1, then y equal to 0, right? So let's say it will be your another point, x equal to 1, y equal to 0. So that will be another points here. Okay, now let's choose another ones here. Then you can see the pattern. Let's say the x equal to -1. So it's -1 minus 1. So it's -1 minus 1 over -1 plus 2. So it's -2. Okay, so now let's see here. X equal to -1, I got a -2. Oh, I think I got it, right? So that means your graph is going to do something like this. Be careful. So this is the asymptote, right? So going to, okay, so here. Sorry, but not supposed to touch the asymptote. So something like that. So it's going to, then you know the other side will go like this. All right. So that's why, because those rational functions are kind of reflecting over the asymptote. So if you can get a one line, you know what is the other side going to become to. Okay, so let's take a look at this ones here, right? So this ones here. Okay, this one I need to do. Okay, so this one's here, maybe I need to do a little bit higher here. Okay, so here, let's do this one here, right? Okay, so here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, so basically, this one is easy to graph because this is y equal to x minus 7. We just need to be careful. I have a hole at x equal to -3. So let's see here. First, let's put x equal to -3 to see what is the value. If you put a -3, you will get a -10, right? So that means that my first point I can graph is -3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10. 1, 2, 3. So in here, you're going to have a holes here, right? So make sure you put a circle, right? So this is a holes there. Now you can choose a few other points. So you will say, okay, so let's see what happens when x equal to 7. X equal to 7, what I have here, -7. Okay, so now let's go to graph my 7. X equal to 7, 0, negative 7, 1, 2, 3, 4, 5, 6, 7. So it's here, right? And now we can choose one more point. So make sure we get it's good. Okay, so let's say that if a negative 4, what is negative 4? It's negative 11, right? So let's do this. So negative 4 is negative 11. Right, so this is my point. Okay, now I can draw a line. So this is a lines here, right? So this is, hey, that's pretty good, right? So that is my line. So make sure for x equal to negative 3, so make sure you have a, you have a circles here, right? Make sure you have a circles here. That's what we say, it's the holes here. So that's what is the graph of these ones here. That looks pretty cool, right? Okay, so good. And now let's take a look at the problem number 7 here. Okay. Okay, so the number 7 here. So they want you to find the graph the functions f of x minus 1 and the plus 1 here. When you do those type of the problems here, the key part is here. You need to find the few key points. From the given graph. Then we can graph it, all right? So from the given graph, those are the point we call this reference point. So the first point I can find is, so will be 0. When x equal to 0, y equal to negative 2. Then I have another point looks like, which one I can find? Oh, looks like I have 2. I have a 2. I have a 2 and I got a 2 also. 2, 2. And the negative 2, 2. Right? So negative 2, 2. So those are the good points I can use. All right. So now let's take a look here. So for here, okay. So first, and this is a part A, right? So then let's do the part B at the same time. So this is my key point I'm going to use to guide me, all right? Okay, so part B is here. We want to graph is negative f of x plus 2. Okay, so the first things here, we're going to talk about horizontal shift. The horizontal shift is the x here. So this is the x minus 1, right? So that means my horizontal shift to what? Shift to the right, right? So the horizontal shift is a shift to the right 1 unit. And there's no left shift, right? Because it's not, so it's right 1 unit. Then this one's here is no horizontal shift. Okay, so let's try to, the same time, so let's try to see we be able to graph it. Okay, so here, this is 1, 2, 1, 2, 3, 4, 1, 1, 2, 1, 2, 3, 4, 5. Okay, so my original point, I'm going to plot it in the, so it's 0, negative 2, and 2 to the 2, and negative 2 to the 2, right? Those are my original course, I cannot do like very well. So I put it in the dot lines here, right? Okay, so the first ones here, you got to shift to the, so I'm going to do the same thing for this graph here. Okay. So this is 1, 2, 3, 4, 1, 2, 3. So 1, 2, 3, 4, 5. So 1, 2, 3, 4. Okay, so here I'm also going to plot the original point, 0, -2, 2, 2, -2 to the 2, right? So this is the okay, so this is my original parent function. Okay, so for here, the first things here they say is shift to the right. So shift to the right, that means I'm moving this point to here, and this point to here, then this point to here, right? So it's a shift to the right. I'm not finish my final product, so my still using dot lines here. And this one does not have a shift to the right, does not have a shift to the left, right? So horizontal shift. Then the next things here we want to see is the vertical shift, right? So the vertical shift here. So the vertical shift is whatever the functions what you add, right? So here, the vertical shift is up 1, right? So shift up 1. So here is the same thing, the vertical shift is up 1, right? So let's try. And this one's here, so these ones are up ones here, right? So that means this point going to go up to where? Go up to here, up 1. And this point go up once to here. And this point go up 1 to here. And that complete all my transformations. So I can finally graph my graph using a solid line. So here, that is all I have here for this one's here, right? Okay, now the next things here. So this one's here, this one, okay, so we also know here, right? So because in here they have, we need to do the, this function first, right? So in here we see there's negatives, right? So we know if it's negative, what's that means here? That means reflecting over the x-axis. And this one is down here, right? So there's no reflecting. So this one is down, so it's no reflecting. Okay, and no stretch, right? So this one is down because the two easy ones here. Okay, now this one's here, that means reflecting over the x-axis. That means you flip it. So this one going to flip up to here. Then this one going to flip down to here. And this one going to flip down to here. And since we not finished my transformations, so this one still is the dotted lines, right? Okay, so this one still is a dotted line. And now the last things here, this is what? This is the vertical shift, right? So I do have the vertical shift. Oh, this is a vertical shift up to 2. Sorry, so here. Yeah, so this is a vertical shift up to 2. All right, so that means I'm going to move up to 2 units here. Okay, so shift up to 2. Let's find my final. So this one going to up 2 units, 1, 2. So going to up to here. This one going to up 2, 1, 2. So going to intersect here. This one, 1, 2, going to intersect here. So that's all your transformations. So now I can use my solid line to do that. You get that? Okay, so those transformations, of course, for these ones here, because I don't have a constant, there's no stretch. Right? So let's say it's no stretches here. Okay, those functions, right? So make sure you know how to find all this transformation. Okay, the last problem for this video. Let's go to the number 8. Okay, so the number 8, we're also doing 2 transformations. This is the f of x plus 1 plus 3. Then the b's here, right? The b's here is 3 f of x plus 1. Okay, so now, like we say, before we do, we need to find the key points we can use to guide us, right? So the key points here, the first one is, I think you can find on the graph is 2, 0. Let's find a few more. Oh, 3, 1 is a good one, right? 3, 1 is a good one. And then let's take a look at any other one. Oh, 6, 2 seems it's a good one. Okay, so 6, 2 is a good one. Okay, so I guess that's plenty point for us to use. Okay, so now, first things here, let's take a look for these functions here, right? So these functions is 3, the x plus 1. So I know there's a shift, right? So this is a horizontal shift. Where is shift to? We shift to where is make x plus 1 equal to 0. So shift to x minus 1. Well, that means a shift of what? Not a shift to minus 1. That means shift to the what? Shift to the left, right? 1 unit. Okay, so it's a shift to the right, 1 unit. Okay, so now let's try to do this. I guess this one I need to be a little bigger. Okay. Oh, sorry. Okay, so this one I need to be a little bigger. Okay, so now let's, so this is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, I'm going to mark where my original point. So this is 2, 0, 3, 1, 6. 1, 2, 3, 4, 5, 6, 6, 2. So it's here. All right, so this was my parent functions here. Not the parent, is what we originally started with. Okay, so the first shift, let's say, shift to the left 1. That means this point is going to shift to here. Then this point is going to shift to here. The 6 is going to shift to here, right? So this will be my first shift. First transformation is my red one. I'm not finished yet. And then I see my another ones here. This is a +3. So I know if I plus anything, so what is, this is what I call it the vertical shift, right? So this vertical shift, I shift up 3 units here, okay? So now let's try to plot it. So this number first shift to here, 1, 2, 3, 3 units here. This one shift up to 3 units, so it's 1, 2, 3. So this one shift up to here. And this one's here shift up to 3 units, so it's 1, 2, 3, shift up to here. Now I complete with all my graphs, so I can use a solid. So this is what is my graph will looks like here. Then I complete all the transformation. So there's no reflecting, right? So for this one is no reflecting, okay? And no stretch. Okay, so now let's take a look at this one's here. Okay, so let's see here. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so now just like we did before, let's graph the original points, right? So 2, 0 is here. 3, 1 is here. 6, 4, 5, 6, 6, 2 is here, right? That's my original graph here. Okay, so now the first thing is here, you see, wow, this number in front. What's that mean? That means this is a stretch by 3. Let's see, how do I stretch? That means times y value by 3. So, right? Okay, so the first one here is 2, 0. So for 2, 0, so 0 times 3 still is 0, right? So this point still remains the same. Now this one is 3, 1. So 3 is the x value, is not affected by it. So it's 3, so there is 1. Okay, so it's 1 times 3. So this point reflecting to 3, 3. So it's 1, 2, 3. So this point is reflecting over here. Okay, so now this one is 6, 2. You times by 3. So what is here is 6, 6, right? So this is 2, 3, 4, 5, 6 here. Right, so this is a 6, 6. This is 3, 3. This one still is 2, 0. Okay, now I can do my graph here, but I'm not finished the whole transformation, so I'm still using dotted lines here, right? So this is what is my graph going to looks like. Of course, it should be smooth, right? Okay, and then the last ones here is I say, hey, add 1, right? So this is 1. This is what? This is the vertical shift. What type of shift? Up ones, right? I go up 1. Okay, so let's take a look. This one here is 2, 0. Now I go up 1, it's 2, 1. This one is 3, 3. Now I go up 1, it's 3, 4. This one is 6, 6. Now I go up 1, is what? 6, 7. And that is all my transformation. So this is what is my graph. Looks like the solid lines, right? So from this ones here, this one is no horizontal or the vertical. Oh no, no horizontal. So this one, no horizontal shift, right? Okay. And we do have vertical shift, no reflecting, right? And now this one's here, we do have a stretch, right? So this stretch is what type of the stretch is here? So is we go up, to the y value. So we have a vertical stretch by what? By 3, right? So we don't have a horizontal stretch. So we say no horizontal stretches, right? Okay, so that's it for this video, we talk about the 4 graphing provinces. So it's very interesting to show you how to graph and the transformations here, right? So make sure you know the differences between the horizontal versus the vertical shift and the refracting over the x-axis or y-axis and the stretch, right? So the stretch is a vertical stretch or a horizontal stretch here. All right, that's it. And we are more than halfway done. And looking forward to talk about the video number 3 to work on more provinces. So make sure you review the video and don't just review the videos, right? You cover up your exam practice to see you will be able to reproduce it without looking the video or not. All right? So it's nice to talk to you, and so looking forward to talk to you again next one. Bye.